Hey everyone. So this is a follow-up to my previous video where I was basically doing building a model, and we did basically I built the model, got completed, and then basically it did an evaluation of it, and that's complete now. And basically there's a score, which is kind of the what is it, square root of the median difference between like what it predicted and there's basically and what it actually got, and there's a formula, and then basically there's a baseline, and there's the difference, and basically the lower this number is, the better the model is. But it basically it said, hey, this is a pretty acceptable, well, not that it couldn't have necessarily done better if we basically provided more data and things like that. There's ways of tuning models, but for basically this is a small amount of data. It's only 200 something rows of data. So for the amount of data that we had, and the small number of columns in it, it's actually not too bad. And then basically what you can do is you can kind of click in here, and you can kind of see, like, basically if this was the target, and then you can see the number that kind of were like under, and you can see the number that were over. And for the most part, we're pretty close to the median for the most of them, right? So for like 20 whatever records, we were pretty close, and then for these 10, we were within 10 of the actual value, and there's 4 that were 20, and so on and so forth, and there were 16 that were 10 or to 20 above, and etc. And you can actually kind of go down into little smaller and smaller bins, so you can kind of see more closer and closer how all the data got distributed out. And as you can kind of see, there is a fair amount of stuff that is kind of overshooting the target a little bit. So this model is not especially great. If we were trying to predict something really important, we wouldn't want more of a Gaussian kind of bell curve. There's too much stuff that's kind of over here on the right, so that we really do need to tune this model a little bit more. Especially you can just see there's just way too much stuff that's kind of falling into the above the target kind of range. But given this very small sample size and all this is actually not a bad model. It could just be better. All right, so basically you go back to your summary page here, and then now I can do batch predictions. I'm not going to actually do that because there's actually a charge associated with doing batch predictions. It's not awful. As I mentioned in my previous video, I'm only paid $1 for all of the stuff I've been doing today and yesterday. But at the same time, there is a cost associated with doing batch predictions that's a little higher than real-time predictions. So basically, here we go. So for real-time predictions, you can either paste a record in comma separated value format, or you can kind of use this table to generate it. So for example, if I want to guesstimate my person's a female, maybe they are 150 months old or whatever, and then the height in is 60, right, 60 centimeters. And then basically I do a prediction, and it will basically predict, oh, this person is probably about 70 kilograms. And then I can go and I can change these values. So let's make you a little taller. Let's make you 70. And I hit that, and I basically get, now I think you're 93, sorry, 93 kilograms. So, or if I make you, really short, 40, and then you're only 47 kilograms. So you can, as you can see, you can kind of play around with the data. And if I, make you male, how does that change it? Now you're 47. So you can go around, you can play with the data, and get predictions out of it. And it's very simple too. I could go and play with this all day, really, just to kind of see where different values fall. And this is a very simple way to build some very reasonably sophisticated models. Now, of course, there are some limitations with Amazon Web Services, and some of this is very technical, but basically Some of the limitations. One is that it only does what's called supervised models, which is basically it's only models where the data you're providing in has input parameters or predictors or features, if you want to call them that, and then there's a target value that's part of your training data. So you have some expected output that you're trying to calculate. So that is what we call a supervised model. Then there is a different kind of machine learning called unsupervised, which basically is I give you a bunch of data. There is no target column that I'm trying to have you predict, but instead what I want you to do is to categorize the data and basically try to find kind of correlations with it. So for a good example is pretend I'm Macy's and I want to find different groups of customers that have similar buying habits. I'm not necessarily interested in putting finding just a couple of customers that are of a particular type. I want to know, well, these kind of people like to buy, shoes. These kind of people over here, they like to buy coats, etc. So I can kind of classify people into different groups. That is what we call an unsupervised model. So Amazon does not do the unsupervised models. The second thing that Amazon machine learning only does is it does what is called a linear regression model. So basically, the model ultimately is linear. There's a linear relationship between the inputs and the output. So there can be, essentially what you're trying to find is weights that determine how important each of the factors is in determining the outcome of the result, but the relationship between each of those inputs is linear with the output, and that's fine. But in some cases, there may be a nonlinear relationship. There might be some kind of curve, right? So the linear relationship is only going to get you so far. Sometimes you need to go up to a more sophisticated kind of modeling in order to more accurately predict certain things. Amazon does not do that currently because they also restrict you to one specific algorithm in the linear regression. There's a lot of different linear regression algorithms. There's a lot of different non-linear regression algorithms, and there's other things like deep forests or random forests and things like that. Tree algorithms and things like that. Those kind of things Amazon does not do. It's all linear regression, and it's all this one singular algorithm, but the singular algorithm is good for a good portion, probably 80% of the linear regression problems are handled very well by the algorithm that Amazon uses. The trick being, though, that it doesn't handle missing data as well. Amazon handles the missing data, but it isn't clear, from the outset of whether it ignores that data or it puts in a calculated median value or something like that. But it will accept data with missing values. But the thing is that when you take out data, you're taking out information, that could be fed into the model in order to, create a prediction. So, missing data with linear regression models just doesn't it's an issue. There are other models, other algorithms that handle missing data much better than the linear regression one that Amazon handles. So you might have to go through and clean your training data before you put it into this model. So anyway, a couple of restrictions, but overall, for a very general purpose, easy to use machine learning service, this is a very cool thing. So that's it. If you guys have any questions, please feel free to reach out to me. All right.